This makes it seem credible, at least, that the sigma notation should have the property that if the counter is running from 1 to n, right, some arbitrary value here, of some function of I, right, like back here, it was I squared plus 3i plus 4. That's what this AI means. This is some function of I. Okay? So you have some function of I here. Right? And that function of I is being added to another one. Right? Some other expression. So maybe the AI here is the I squared, and the BI is the 3i. Right? These are pieces here, right? Different terms. So if you have a sum, and the sigma notation is applied to a sum, then what happens is you can apply the sigma notation to each of the terms in the sum separately, and then add the results after the fact. So it's a standard distribution property. The derivative had this property. The integral is going to have this property. Right? And the sigma notation has this property. Right? Okay. Not only that, we saw that constant multiples moved outside, right? The 3 moved outside the sigma notation when it applied itself to each term, and so did the 4. So that leads us to believe that if we had a constant multiple times something which is dependent upon the counter, upon I, that this value c, which is not affected by I here at all, should be able to move to the outside of the sigma notation and be applied after the fact. Again, like the derivative has this property, and the integral has this property. Okay? So this would be just as effective with a difference. It would not matter at all. So here's our sum difference property, just like we had for derivatives, sum difference, and the constant multiple property, just like for derivatives, even though these are not derivatives at all, of course. But it does share this property with them. Right? Having both these properties together, you call this operator a linear operator. All right, so let's take another example very quickly here. And we'll take the sum of I equals 1 to, let's say, 5 terms. And the function is 2 minus 5i. As you see, is dependent upon I in some way, 2 minus 5i. But this time, instead of just writing all the terms separately and add them together in the most direct way, I'm just going to use these properties a little bit just to illustrate how they work. So the first thing I can do is move this summation inside here. Okay, so I'll have the sum of 2, I equals 1 to 5, minus the sum of 5i, I equals 1 to 5. I can do that because of the first sum difference property. Right? It distributes through this difference. Now I can move the 2 to the outside and the 5 to the outside both, because of the second property, because of the constant multiple property. So I have 2 sum of, now it looks like nothing's written in here now, but as I was explaining before, that means it's really like a 1, right? Like the invisible 1 I had here a moment ago, because this is really 1 plus 1 plus 1 here, right? So the sum of 1 from 1 to 3 is, of course, 3, right? 3 times 4 is 12. That's 4 plus 4 plus 4 here. So down here, you can write 1 if you want, or you can leave it blank as long as you know what's going on. Minus 5 moves to the outside here, but I is trapped inside. It cannot move to the outside because I is the counter, right? It depends on I. So I cannot just jump outside, but the constant multiples can. Okay, now that we have this, we can go ahead and continue the computation. We'd have 2, and just like before, when right, sum of 1 from 1 to 3 would be 3 4s that we're talking about. So the sum of 1 when it's from 1 to 5 will be 5. We have 5 2s here, really. In other words, if you were to write this out directly, each term you would write and add together would have a single 2 in it. and you'd have 5 2's altogether. That's all this is expressing over here. So you'd have 2 times 5. 2 times 5 for that. Minus 5 times something. What's the something? Well, the sum is just, it's I over and over again, but I is changing. So it's 1 plus 2, and then 3, and then 4, and then 5. So 1 plus 2 plus 3 plus 4 plus 5, which should be 15. So we have 10 minus 5 times 15 is 75. So 10 minus 75 is negative 65.